Hello, QST readers worldwide. I'm Dave Kassler, amateur radio call sign KE0OG, with a video adding further notes to the December 2021 Ask Dave column in QST. I want to follow up on the idea that coaxial cable can become unexpectedly lossy in the presence of a high SWR. Although your tuner may be able to match a wide range of SWRs and thus appear beautifully matched to the transmitter, a high SWR will increase the line losses in your coax. This video takes a look at how that happens. Hams use quite a variety of coaxial cables. Nearly all of it has a characteristic impedance of 50 ohms or very close. Here is an example of one popular cable, the high-end LMR 400 cable from Times Microwave. A few years ago, I purchased an entire 500-foot spool of this cable, and I'm still working at using that up. In the figure, we see the end of the cable where I cut it apart so that you can see what's underneath. The cable itself has a very strong plastic outer cover, which is UV resistant. Just under that, we find a layer of copper braid. This copper braid is tinned with solder so that it will not react with the next layer underneath, which is a piece of aluminum foil that provides 100% coverage. Underneath that, we find a foam dielectric which keeps the center wire separate from the aluminum foil and the copper braid. The inner conductor is kind of unusual. It's a piece of heavy aluminum wire that is coated with copper. It's done in such a way that the copper is deposited on the aluminum. One thing that may seem odd is putting copper and aluminum together, because they are dissimilar metals, and if any air or water comes in contact with a scrape in the copper that shows the aluminum underneath, corrosion can occur. But it's very tightly wrapped in that dielectric, so corrosion is unusual. Note that the copper braid will wick up water, but the solid aluminum shield will not. Now I just want to look at some cables that are very common in amateur radio. There is RG8, RG58, RG8X, LMR 400, LMR 240, and both 450 ohm and 600 ohm parallel wire line. RG8 is the first coaxial cable that became popular among ham radio operators. A lot of it was generated during World War II and was available on the surplus market after the war. RG58 is a smaller cable that handles less power and is fairly inexpensive. Neither have 100% braid shielding. The RG8X cable has come along more recently. It is slightly larger in diameter than the RG58 and is usually my favorite cable because it's quite flexible and easy to use. Although Times Microwave has been around for a long time, their cables have only in the last couple decades become popular in amateur radio circles. As we saw in the picture of the LMR 400 cable, it's extremely well built and can handle quite a bit of power. There are two types that are popular in ham radio. The first is LMR 400, which is available in a variety of styles, including solid center conductor and stranded center conductors, which make the cable more flexible. The other popular cable is LMR 240, which is comparable to RG8X. Times Microwave also makes specialized and rather expensive high-quality crimp conductors for the cable. We're going to look at a few cables in the ARRL antenna book. Table 23.1 shows the nominal characteristics of commonly used transmission lines. I might argue with whether these are all commonly used, but it does include most of the cables hams use. Note the example under RG8. There are several manufacturers, and one manufacturer, Belden, makes several varieties, as do others. They are all about 50 ohm coax. RG8, sometimes noted as RG8U, has been popular for many years. It has a solid polyethylene core, which is as tough as a rock and as hard to use. The more modern coaxial cables have foam cores, which are easier to cut. One problem with the foam core is that if you bend the cable too tightly, the center conductor can migrate to where it touches the outer core and shorts out. So be sure to follow the manufacturer's instructions on how tight a bend radius can be. The bend radius is the distance from the center of the circle to the cable. For example, if the bend radius is 4 inches, that means a 180-degree circle will be 8 inches across. Now let's look at RG8X. It's also 50 ohms. It can have either a solid core or a stranded flexible core and is very often designed with the foam core. Compare the matched loss figures between the RG8X and the RG8. They're similar. So for ordinary HF work, you don't need to buy the more expensive RG8 cable. Now let's go down toward the bottom of the table and look at RG213. There are several types of this. It is a heavier cable than RG8X. It's about the same size as RG8. But one of the very nice things about RG213 is that it is very flexible. And it has about the same loss characteristics, give or take, as the other two cables we just talked about. Now, oddly, LMR 400 is not on the table, but you can see that LMR type cable has outstanding low loss characteristics, and this is why a lot of hams use it exclusively for VHF and UHF. Like I said, I have a large reel of LMR 400, and that's what I use for new projects. In fact, I just made a long LMR 400 cable so I can do a test of the DX Commander antenna. Now let's look at parallel lines, sometimes called open wire line, although the 450 ohm line is better referred to as window line. Note the very low loss characteristics of this line. You just can't beat these low loss characteristics with coaxial cable. So why do we so often use coaxial cable when open wire line has such low loss? Well, one of the reasons is that unless the open wire line is balanced and matched exactly right, it will release RF along the length of the line, which means it acts as an antenna and can cause problems with RFI in the shack. Now there's one more thing I want to show you on this chart, and that is the approximate power handling capability of these various cables. The RG8 and the RG213 can both handle up to 1,000 watts on 6 meters. The RG8X cannot handle this much power. And this is why we go with bigger cables if you have an amplifier of any sort. Otherwise, the cables just turn into a big long heater. Okay, that was a little bit of background to some of the common coaxial cables used by ham radio operators. Now, let's look at this table from the antenna book that also appears in the QST article. If your feed line is perfectly matched and you have a 1-to-1 SWR, the only loss you have will be the resistive loss from those tables. Note that loss always goes up with frequency. So I will concentrate on the 30 meter band, which is a little bit above 10 megahertz, and we'll take a look at what happens when that lovely 1-to-1 match becomes a mismatch. Note the x-axis in the drawing shows the line loss in decibels when matched. And then if you have a high SWR, you are going to get more losses. Sometimes this is significant, and sometimes it's not. Let's just take a simple example of a cable that has a hypothetical 1 dB loss and is mismatched so that the SWR is 2 to 1. Draw a line up from 1 to the thick line that says SWR equals 2 and go over to the y-axis, and we see that we have to add 0.2 dB to the line's intrinsic loss of 1 dB for a total of 1.2 dB of loss. The extra 0.2 dB of loss is insignificant. But there are lots of very wide-range tuners out there. Usually they can match to an antenna/transmission line combination with an SWR of up to 10 to 1. That's a really bad mismatch. And let's look at an example of one. This figure appears in the QST article. It is approximately correct for RG8X cable in the 30-meter band, or around 10 megahertz. The bottom line shows the cable's theoretical loss at 10 megahertz for a 100-foot line. That's not an unusual line length if you have to route it all the way from your transceiver down to the ground system and out and around to where the antenna is. One common mistake made by new hams is to vastly underestimate how long the coaxial cable needs to be to go around all of the kinks and corners on the path from the transceiver to the antenna. One suggestion is to lay out a rope exactly the same way you would place the cable, and then measure it and then add 20%. Anyway, let's assume that we have some really awkward antenna and coax that together has a 10 to 1 loss. The top thick line is SWR equals 20. The line below that is SWR equals 15. And so the line we touch is the SWR equals 10 line. Now let's put that over to the y-axis, and we see that we need to add nearly 2 dB to the losses of the line. Now if you add 2 dB to 0.7 dB intrinsic loss, we have a 2.7 dB, which is very close to 3 dB, which means we lose almost half of our power in the feed line. The lost energy has to go somewhere, so it is radiated as heat. Not a good idea. Okay, so the point of this article was just to show that a bad mismatch between the tuner and the antenna and transmission line can lead to significant losses in power. Remember that a loss of 3 dB means a full half of your power is turned into heat in the transmission line. Now, frankly, this is not terribly common on HF. But if you're doing loop designs and feeding them with open wire line, the loss can become significant. This is why we do not feed non-resonant antennas with coax. The SWR of these antennas can be very high at the antenna feed point. This shows up as a very high SWR for the tuner to match. Even though it will likely match it, there will be high line loss in coax. One way to avoid this in extremely high mismatch situations, such as 43-foot verticals, is to place a remote tuner at the very base of the antenna. So in essence, there is no transmission line between the tuner and the antenna. That way there are no feed line losses. Such tuners are available from ICOM, Yaesu, and MFJ, as well as others. They are controlled through the coax using DC voltages, or sometimes by means of a separate cable. The remote tuner is connected to the transceiver via ordinary coax and sees 50 ohms at each end, so you won't lose extra power due to the mismatch. Sometimes this is the only way you can make an antenna work. So there you go. A little discussion about coax losses in high SWR situations. It also explains why we sometimes use open wire line instead of coax. I hope you found this helpful. If you would like to submit questions to the Ask Dave column, send them to AskDave, all one word, at arrl.org. Or you can send them to Ham Radio Answers, all one word, @gmail.com. I look forward to seeing your questions and comments. If you think I've made a mistake, which I often do, send your concern to askdave@arrl.org. In the meantime, please get on the air and enjoy those hard-earned privileges. Until we next meet, 73.